Okay, now we are continue with structured programming. Alright, so what is structured programming? Structured programming aim on improving the clarity, quality, and development time of programming by making extensive use of subroutines. Using a subroutine, you use the block structure to do a programming. You use the for and while loop in order to make your programming more clarity, more simple than others. Right? There are five basic structured programming in any of the language. Okay, in any language there are five basic structured programming. The first one we call it as a if then, and then followed by if then else, while, do while, and for. So this one here already always used in the C programming. So in AVR, we can use BRCC to emulate the structured programming techniques present in the C programming. Okay, instead of using the if then else, while, do while, and for loop, we also can use the branch instruction in order to emulate these five basic structure programming. Right? So this one in the next slide we will learn how to do a structured programming, okay, given a C program, and then we are going to write down in the assembly language. Right. The first structured programming that we are going to learn is if then. Okay, so this one here is probably the simplest of structured programming. Okay, so if you can see here, all right, this one here, okay, this is a, if you see here, if you read this programming, it says that if n equal to 1, and then what happens is if yes, m equal to 3, but if n not equal to 1, then what happens is you exit your loops or your case, right? So how we are going to do, how we are going to write down this C programming to assembly language, right? To do that, right? So first thing first, what you're going to do is make sure that you draw the flow chart first. Why flow chart? Because we want to see how are we going to do the structured programming. So it's easy to us to write down the programming later in assembly language. So this is the flow chart for if then, right? If you can see here, if n equal to 1, is it n equal to 1? Okay, of course lah, we start with starting here, and then you have the case here, case structured, okay, in which is it n equal to 1? If yes, what happened? If yes, m equal to 3. If not, then what happen is you exit the program. Okay, so in this case here we have two solutions. Okay, the first solution here is you're going to use the, if you going to pick the y here, all right, so that is your first solution. The second solution, where you want to take this n here, okay, for y, since this is equal, all right, so you see here, if n equal to y, if, all right, so if yes, what happen is, what type of instruction that you're going to use is, in this case we're going to use the text box. Okay, so this one here we're going to use the BREQ instruction. Okay, what happens if no? Okay, what type of instruction that we're going to use? Okay, for the no, we can use the BRNE, which is branch not equal. So this one here you can find out, all right, in the previous slide. Okay, which type of the programming that you're going to use here, right? The instruction that you're going to use according to your question or problems. All right, so this one here we use the BRNE and BREQ. BREQ, if yes, we use the BREQ, means that branch if equal, yes, n equal to 1, then we branch. If not equal, then we use the BRNE. Okay, So the first solution there. All right. So let's look at the first solution. All right. The first solution. Okay, so this is the first solution. All right. So I make this paragraph. Okay. All right. The first solution. First solution. Okay. First, what are you going to do? Alright, so since this one here we're going to use the BREQ. So firstly first, how to, okay, how to write in C programming, how to represent the N and M here. Okay, to do that, let's assume that, okay, let's assume N is R16, okay, while M is R17. Okay, you just assume, okay, you make your N here equal to R16, while M go to your R17, right? So this is how I'm going. This is how we want to write down the program, right? So you start here, okay? So we just ignore the start because we no need to initialize anything here up here. So here, what are you going to do? What instruction are you going to do? In this here, we want to compare the R16 with what value? With 1. Okay, so you can use the CPI, compare immediate. So CPI, okay, R16 with 1. Okay, you're going to compare R16 and 1. Okay, then after that, followed by your branch. After you do the comparison, then you can use the branch instruction here. Okay, so BREQ, okay, branch equal. If equal, what happen is, okay, you go to summer, or you can put any names. Okay, so this label summer here, you can put down here. Okay, this is your summer. Okay, this is your label summer. What happen for the label summer? Okay, if yes, what happen? M equal to 3. How to make your R70 equal to 3? You can use the LDI instruction. Load I R73 3. Okay. We just put something like this. Okay, so mine, because I don't want to see what we call element LDI, okay, R73. Okay, and then after you put 3 to your R70 or M, what happen? You go to N. Okay, so this one here you go to N. So what happen if this one not summer? Okay, what happen is R16 is not equal to 1. So when R16 not equal to 1, what happen is you go to N. Okay, you can use the jump done. Okay, the question is where you want to put this label done here. Okay, either you just put here or you need to put somewhere else. Okay, in this case we need to put our done label done here. Why? Because if put here, alright, so for example okay, you put NOP here, what happen is, after it execute this NOP, then it will go to the next instruction, which is LDI R73. Okay, remember that your program always go from top to bottom. Okay, so in this case here, you just told the CPU to go to done, which is this is your done. Yeah, suddenly it's jump to here and NOP. NOP is you do nothing lah. Alright, so this is the first solution. Okay, if you're going to use the BREQ. What about for second solution? Okay, for the second solution, okay, so this one here, we are going to use the BRNE instruction. Okay, how to do that? Again, similar. Okay, you just first, what you're going to do, compare your R16 with what number? With 1. After you do a compare result, and then use the BRNE. Branch not equal. If R16 not equal to 1, what happen? You jump to done. Okay, go to done. Okay, so you put this is your done. Okay, what are we going to write to our done? Okay, so do nothing. NOP. Alright, so we finish this part here. What about this part? Okay, if n equal to 1, what happened? So if n equal to 1, so you write down here LDI R17. Okay, then after that you go to n. So you already have done here. So that's it. This is the second solution and this is the first solution. Okay, the difference is for the second solution you only use the 4 line of instruction, while for the first solution here you need 5 lines of instruction. Okay, that is for the if then, right? So this one is the most effective way to code, which is this to skip the code block if the question is true. Alright, next we're going to see the if then else. So the if then else construct has alternative statement that is executed when the condition is false. Okay, so example here, if n equal to 1, if yes, n equal to 3. If no, what happen? N equal to 2. How are we going to write down this program here? Right, so to write down the program here, as I mentioned earlier, so you need to draw your you need to draw your flow chart, okay, so that you can see how you're going to do the programming clearly. Alright, so this is the if then else flow chart. Right, you see here, if n something like 1, what happen? M equal to 3. If no, m equal to 2. Again, in this case here, we have 2 solutions. Right, so for the n equal to 1, you can use the BREQ, similar to the previous one. Alright, and for this one here, you can use the BRNE. Okay, one is equal, the other one is not equal. Okay, again, similar to last time. Alright, so let's assume that N16, right, is your n, while m equal to R17. So let's do the first solution. Alright, so what is the first solution here? I put to 0. Alright, so the first solution. Okay, first, what are you going to do? Again, you need to compare. Okay, use the CPI, and what is your n? R16. What number you're going to compare with 1, and then BREQ if summer. Alright, so if summer, what happened? If summer, you go down here. Okay, so this is your summer. What happened when n equal to 1? When n equal to 1, you need to load your m, which is your R70 with 3. So you can use LDI R70 3. Okay, and then after that, what you're going to do? Okay, see here. Then you go to done. Okay, and OP. Okay, finish. Okay, do nothing. Alright, next. What happens if n not equal to 1? If n not equal to 1, then what happens down here? You load I R70 with what number here? Number 2. Okay, and then after that, you need to go to n. Okay, if I leave my programming like this, what happens? Is it correct or not? Not correct. Why not correct? If I leave my programming like this, so what happens is after you execute this instruction here, then you need to execute the next instruction, which is this one. Okay, which is you need to load IR70 with 3, which is wrong lah according to this flowchart here. After you load your m with 2, then you go into n. So here you need to add another instruction, jump done. Okay, where is my done? So this is your done. Okay, you can put here done. No operation. Okay, so this for the first solution. What about the second solution? Solution. Alright, for the second solution, again, what you're going to do is you need to compare this number here, okay, by using CPI. Okay, CPI R16 with what number? Compare with 1. Okay, after you compare, then you use the BRNE. So this one is BRNE. Okay, so what happened if BRNE? Okay, you go to tab summer. Okay, where is my tab summer? Okay, you can put down here. This is your tab summer. What happened when tab summer? Okay, the n not equal to 1. What happened? Okay, what happened? You going to make your m equal to 2. So how to make m equal to 2? You use the LDI. Okay, LDI R17 with 2. Okay, then what are you going to do? Then NOP lah, done. Right. So this is for the tab summer. What happens if n equal to 1? When n equal to 1, then you need to, okay, this for if the case is no. Whatever if the case is yes, then load I R17 with 3, and after that you go to n. Alright, so jump done. Okay, and then I put where I want to put my done, so I can put done. This is my done. Okay, so this is the solution and the second solution for the if then else structure programming. Okay, next is while programming. Okay, so this one isn't a whole lot more difficult than if. It's quite simple actually if you know how to draw the flowchart. Alright, so let's see here. Okay, while m is greater or equal than n, If yes, n plus plus. If no, exit the while loop. Okay, so how to do that? Again, from this uh, program here, we can make our flowchart, right? This is your start. Is m greater or equal than n? If yes, what happen? See, n plus plus. If no, you're going to n. Okay, again, you need to assume that n equal to R16, y m equal to R70, because we're going to write in assembly language. So assembly language, we need to use the GPR. Alright. So this one, alright. So you see, this is greater. Okay, greater and equal, and then the other one is y and less than m. What is the instruction that you going to use? Okay, so for this one here, the one that we're going to use is alright. So this is a conditional branch instruction. So in this case, we are going to use the greater and equal, and the other one is lower. Okay, so you can see here you have two type of greater and equal. Alright, the first one is this one, BRSH, branch if same or higher. The second one, you can use the BRGE, branch if greater or equal. What are the difference between BRSH and BRGE? The difference is the second one. Okay, the first one is for the unsigned number. Okay, which is you can use any positive number. But for the second one, you're going to use with the signed number, right? So in this case, we're using the BRSH for branch if same or higher, and BRLO for branch if lower. Okay, we are not going to use the BRLT, in which this one is branch if less than 0 is for the signed number. Okay, so this one if yes. Okay, what instruction they're going to use? This is BRSH. If low, if n is greater than m, or if m is lower than m, why when n, sorry, so we use the BRLO instruction. Okay, this one here you have two solutions. One, you can use the BRSH. The second one, you can use the BRLO instruction. Right, so let's do the first one here by using the BRSH. Okay, so this one. Alright, so first, okay, you started, and then after you start, what are you going to do? You want to compare m with n. Okay, so in this case here we use the CP instruction. Compare m with m. What is our m? R70. What is n? N is R16. Okay, make sure that you use the correct what we call here, the correct variable here. Okay, because this one here you want to compare m with n, not n with m. If you're going to compare n with m, then this one here become R16, R70. Right, so in this case we're going to compare m and with n, so we're going to use the R17 and R16. Okay, next we're using the BRSH first. Okay, so BRSH. Okay, why when BRSH means that m is besar, greater than n. Okay, so you should put the besar here. So down here, go down. What happen when besar? Okay, when besar, what happen? N plus plus. Okay, so you need to increment your n. Okay, you can use the INC R16. Increment your n. Okay, and then after you increment your n, what are you going to use? Jump ulang. Okay, you see here, you need to repeat again. Okay, and then check the compare m with n. So where I'm going to put my ulang here, so I need to put here ulang. So this where is my ulang? Yes. What happened here? Right. So this is my ulang. Okay. Jump ulang. Next, I compare again. R70 is R16. Is it R70 is greater than M? Yes, it's greater than. Go to besar, increment my R16 and jump to ulang. If not, what happen? If no, so if no, then we jump to where? Done. Okay. So where I'm going to put my done here? Alright, so I put down here because we already finished. Right, so we can put done. Okay. What instruction I'm going to use? NOP. Do nothing. Okay, so this for the first solution. Solution. What about the second solution? Okay. Second solution. Okay, for the second solution, I'm going to use the BRLO instruction. Okay, again, same with the first solution. First, you compare your R6. Okay, CP R17 with R16. Okay, after you compare, you use the BRLO. Okay, so BRLO means that M smaller than N. Okay, so we use the kecil, label kecil. Okay, you just use the label kecil here. Okay, what happens when kecil? When M is smaller than M. Okay, when M is smaller than M, what happens is, you see, I'm going to N. Okay, so NOP. Right. Next, oh sorry. This is for if the what we call if the case is false. If the case is yes, what happen? Okay, if the case is yes, what happen is I need to increase my R16. And then after I increase my R16, I need to go here. I need to repeat, do the compare once more. Okay, so I jump ulang. Okay, so where is my ulang here? Where I need to put my ulang? So I need to put ulang at the compare instruction. Okay, so this is the solution for while loop. Okay, next. Okay, we already finished the while loop. And the next is the do while. Okay, so do while is a looping structure that doesn't compute the test before entering the loop. It runs the loop once and then compute the test. Okay, means that you need to compute first your loop and then after that you do the comparing. Alright, you see here, do n plus plus, or you do the n plus plus first, and after that you use the compare the m greater than n. Okay, so in this case here, okay, again, we draw our flow chart. So this is the flow chart. Okay, you start, you do the n plus plus first, okay, and then you do the comparison, Is it m greater than n? And if yes, ulang. If not, you go to n. Okay, again, in this case here, alright, let's and let's our n and m equal to R16 and R17 respectively. Okay, so first solution and second solution. Okay, you have first solution and second solution. Alright, so this one here, for the first solution, we are going to use BREQ instruction, while for the second solution, we are going to use BRLO instruction. Okay, for the first solution, how to do that? Okay, first, what you're going to do? Okay, you need to increase your n. Okay, increase R16. After you increase R16, what happens? You compare R17 with R16. You do the comparison between your m and n. After you finish compare, okay, then you BRSH. Okay, use the BRSH. Alright, so BRSH ulang. Okay, where I need to put my ulang? I need to put my ulang in this instruction here, INC R16, because you see here, this is your arrow here before your n++. So you put here, this is your ulang. Okay. What happens if m smaller than n? When no, so when no, then I go to n. Exit my program. Okay, my press slide. Okay, this is for the first solution. Then let's look at the second solution here. Okay, for the second solution, again similar to the first solution. First, I need to increase INC my R16. Okay, increase my n, and then compare R17 with R16. Okay, I compare R17 with R16. After I compare, I use the BRLO. Okay, I use the BRLO instruction. And then what happens when using a BRLO? I go to n. Okay, so done. Go to done. Okay, so where is my done? So this is my done. Okay, under my done, what instruction I'm going to use? And do nothing. This is for the false or no case. Okay, what about when yes, when m is greater than n? So when m greater than n, what happens is I need to I need to go to jump to ulang. Okay, where I'm going to put my ulang here? This. Okay, before next instruction I'm going to use is n plus. Right, so that one is for do while, and last but not least is for the for loop. Okay, so to finish up all the looping structure present in C, we might as well show the for loop, though it's really nothing new. So this is the for loop. Okay, if you can see here, just okay. First, you clear your n, and then after that, for m equal to 1, m less than 10, m plus plus. Okay, what happens if true, and then n equal to m plus n? If false, what happens is you going to end your program. Okay, so again, as I mentioned previously, right? So you're going to draw your flowchart, right? So this is your flowchart. Okay, this is your starting. Right, start. Okay, you see here start. Okay, m equal to 1. Okay, no need to n equal to 0 because you can do that n equal to 0 depend on you. Okay, fine. In this case, okay, we just do the n equal to 0, of course. Okay, n equal to 1, and then this one is n equal to 0. Okay, next. After that, you do a comparison. Is m smaller than 10? Is smaller? Yes. What happened? You need to go into okay, n equal to n plus m. This first, and then after that, n plus, and then you loop again. Okay, compare again. Either m smaller than 10. If m bigger than 10, what happens is you go to S3. Right? So for this one here, again, you have two solutions. The first one you can use the BRLO, the second one you can use the BR. What happened here? Alright. Okay, so this one here, we're going to use the BRSH. This one here, we're going to use the what happened here? This one, yes. Alright. Okay, this one BR L. Okay, again, let's assume our n is R16 and m is R17. Okay, first solution. Okay, how to do the first solution? Okay, the first solution here is we including the BRSH. Okay, first thing first, what you're going to do? Alamak, I already delete this one here. Okay, so first thing first, if you see here, before we start, we need to clear R16. Okay, make our n equal to 0, and then at the same time, okay, after that, what are you going to do? Load I R17 with 1. Okay, you need to initialize. You need to initialize so that your m equal to 1. Okay, after you initialize m equal to the 1, then after that you can do the CPI R17. Okay, with what number here? With 10. So that's why we use the CPI, because we want to compare with 10. Previously we want to compare with n, so that we use the CP. In this case here, we want to compare with immediate value 10. Right? And then after we compare with 10, what happens? Okay, we do the BRSH first, and after that we do the BRLO. Okay, BRSH is what happens when BRSH if greater BRSH. Okay, when BRSH, oh sorry, this is BRSH supposed to be here. Okay, this is a BRSH, and this one is supposed to be BRA. Oh, sorry for that. Right, for the BRSH, okay, what happens when BRSH? When BRSH, you go to 10. Okay, because your m greater than m greater, so you go to n. So this is done. So what instruction I can put here? I put the NOP. Okay, this is for the when the case is false. What about when the case is true? When case is true, I need to add, okay, R16 with R17. Okay, you see n equal to n plus n, which is here n plus equal to m. Okay, so it actually n equal to n plus n, and then I need to m plus plus increment R17. After I increment R17, what I'm going to do next? So after I increment, I need to compare again. Okay, so I need to jump ulang. So where I need to put my ulang here? So I need to put here. This is my ulang. Right? So this is for the first solution. What about the second solution? Okay. Solution. Okay, for the second solution, similar to the first solution, first I need to clear R16 and load R17 with 1. Okay, and then after that, I need to compare R17 with 10. Okay, after I compare R17 with 10, then I use the BREQ. BREQ. What happens when BREQ? When BREQ means that my numbers here, M is smaller. So I put a kecil. Okay, so under the label kecil, is a kecil. You can see that one. Okay. Okay, so I need to load. Sorry, not load. Okay, when kecil, M smaller than 10, I need to add R16 with R17. After I add them, then I increase my M, increase R17. Then after that, I go to compare, ulang to compare. Jump ulang. So I need to put my ulang, so I need to put here. Right. This is for the smaller, or the M is smaller than 10. What happens if my M is greater than 10? Alright, so when M is greater than 10, what happens is for the false case here, so I jump to done. Okay, go to done, lompat to done. So where is my done? So this is my done. Done, and then NOP. Right, so that is for the structured programming.